All right, today we're going to talk about PC power supplies. This is an important topic because they're the most popular item that needs to be replaced in a PC. Also, they provide a challenge for students when they're trying to troubleshoot PCs because a lot of them don't understand how they work and how to actually troubleshoot them. So that's what we're going to do today is talk about the major parts of a power supply and then how do you test it. Okay, so we're going to start off with the first part of a power supply. The first part of a power supply basically is a transformer, and what it does is it takes the voltage from your outlet, which is at 120 volts, and it's going to step it down to a voltage that's needed for your computer. All right, so that's a fairly simple part of the power supply, but it does an essential task within the power supply itself. Then what we need to do is the power supply is going to take this voltage, which is AC, and it's going to convert it to a pulsating DC because the computers work on DC voltage. It's important to sort of know this one because this is a very vulnerable part of a power supply, and a lot of times this is the part that goes bad when we get things like surges and other electrical problems within a building. Okay, from there then, we take that power that's pulsating DC, and what we need to do is smooth it out into a smooth, consistent DC source, and that's what the filters do within a power supply. Now this is sort of important because a lot of times we will buy devices to help filter the power that comes into our computers, and what they're going to do is assist this component of the power supply. Power supplies are very vulnerable to things like spikes and surges within the electrical lines, and this is part of the power supply that first of all tries to smooth the power out, but also protects us against some types of electrical problems. All right, then we get into one of the most important parts of the power supply, which is the regulator. Now what the regulator basically does is we have many different voltages in these power supplies. In fact, modern power supplies, we have even more voltages that are applied to the motherboards because CPUs require less and less voltage, so they have to have their own regulators nowadays. In some cases, we have to have multiple regulators. But every voltage that the power supply provides has to have a regulator. So it comes in at a higher voltage, let's say 24 volts, and we will get a very stable regulated output at our positive 12 volts, negative 12 volts, positive 5 volts, negative 5 volts, and the other voltages are used for our memory and our CPU and other devices. Why is this important? Well, if you know what voltages are used for different parts of the computer, you can pretty much identify what's gone wrong with the power supply. You know, for example, the motors within your PC, anything that has motors, like drives, hard drives, things like that, use 12 volts. Other components will use 5 volts. And then other components will use other voltages like 3.3 volts or others. But if, let's say, the 12 volts went bad, you would find that your motors wouldn't spin on your hard drive. They wouldn't spin up. Well, that would be a good idea that the power supply is bad and must be replaced. Right? Finally, we get to the last part of the power supply, which probably poses the greatest challenge to students to understand this whole concept of self-test feedback power protection. Basically what that is this, is that each one of these voltages that come out of our power supply and are fed to the motherboard and the devices within our systems are tested, and there's a feedback that comes back that says the proper amperage level and voltage levels are detected on the motherboard, and it keeps the power supply up and running. But for instance, let's say that something's shorted out on the motherboard, we would see an increase in amperage, we might see a decrease in voltage. There's a processor in this section that would come back and tell the power supply to shut down. So I don't know if you've ever experienced this, but sometimes you may have had a PC for a sudden surge, the whole system shut down. You turned it back on and everything was fine. Well, that's what this is supposed to do for us. It's supposed to protect the other components within the computer that are more expensive, and it's to make sure that we only deliver good power to the components within the computer. Now, what's the challenge here? Well, the challenge here then is how do you test a power supply? Typically, what students will try to do initially is they will pull a power supply out of the PC and they will try to do voltage readings on the output of our power supply. And they'll find that they get no voltages. Well, it makes sense they get no voltages because when you disconnect the power supply from the motherboard, you disconnect this connection, which shuts off all the power. So in order to test power supplies, you have to have a special device. You can pull the power supply out, plug it in, and there's a tester that you need to plug in to the power supply itself that will test each of these voltages, and it will generate the good signal back to the power supply itself. So it's very important for students to understand that you cannot test a power supply outside of a computer without having a special testing device that provides this feedback. Okay? And it is also important that students understand that this component protects our system, And many times that's what shuts down our PCs, and when they come back and they work properly, what it's done is it's protected maybe a hard drive from failing or the motherboard from shorting out or whatever. So it plays a very important role within the computer, and it protects the rest of our devices. All right, this is basically an overview of how power supply works and the different components. So again, 4 parts. We have a transformer, a rectifier, filter. We come back, we have a regulator, and the self-test, feedback, power protection, and that basically makes up the 5 components of a power supply and how they work. So thank you for joining us for an overview of power supplies.